Hello, ladies and gentlemen. Welcome to your new 8th grade science class. My name is Miss Jacobs, and you look fantastic today. Is that a new shirt? Wow, you look great. Just kidding, I cannot see you. This is a recorded video, as will a lot of your science lessons be this week. How this is going to work is that all of our 8th grade science teachers are going to share with you different lessons over the next couple of weeks, and we will be able to have a live class once a week. Details to come on that. So let's go ahead and get started today. For our class today, we are going to go all the way back to the beginning of school. We're going to look at what matter is, physical and chemical properties of matter, and physical and chemical changes. So give me a moment to adjust my screen and pull up our show today. Dun, 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 dun. All right, there we go. So, as I said before, we are going to be looking at physical and chemical properties and changes in today's lesson. And then after this, we will have a very short Google Classroom review assessment that you can take to just recall some of these concepts that we've talked about today. So let's go ahead and get started. So day one, we looked at what matter is, and we said that we can describe matter, and we use these descriptions or characteristics of matter, and we call them properties. So if you were to look at this tree in this picture here, we could describe the matter by calling out some of its properties, like saying this tree is green, or this tree is tall, and if we struck it with lightning magically, it could catch on fire. You could say properties of myself. I'm matter. We can say Miss Jacobs has red hair. She has very fair skin and freckles. And she's awesome. Absolutely. All properties of Miss Jacobs. Again, looking at characteristics. So there were two properties that were shared by all matter that we talked about. Does anyone remember what they were? Great job. We said that all matter has both mass and volume. Because of this, all matter has mass and volume. What else does all matter have? Give you a second. Wait for it. Wait for it. If you said density, you would be correct. Does anyone remember the formula for density? Density equals mass divided by volume. Good. So let's move on here. These are the two properties or characteristics that are shared by all matter, but we know that matter is unique and it has very unique characteristics as well. So let's start off by looking at physical properties. I'm going to move my webcam here for us. So physical properties are determined by looking at your five senses. There we go. Or they can be measured. And we talked a lot about these in class over about a week or so. We talked about conductivity, so whether or not that matter can allow an electric current to pass through, or the opposite of conduct if it's a conductor. It could be an insulator, which means it doesn't allow for an electric current to pass through. We talked about ductility, which was the ability to be stretched into a thin wire. We also looked at density, which is the amount of mass per unit of volume. Remember, mass is the amount of matter in something. Volume is how much space it takes up. We used this word called malleability, and we said that we can see the word mallet in here, which is the ability to be molded or flattened into a thin sheet. Let's see. We then moved on to solubility. Solubility was the ability of a substance to be dissolved into another. Color, we could say my shirt is gray, my hair is red. Smell, your armpits smell of roses right now, I'm sure. Taste, your mother's cooking is tasting awesome, I bet. Hardness, the hardness of this kitchen table right here is not as hard as a diamond ring would be. State of matter, whether or not something is considered a solid, a liquid, or a gas. You can observe something's boiling, freezing, or melting point. The temperature at which it changes state of matter. We also talked about just noting something's temperature. Your body is probably close to about 98.6 degrees. Specific heat, which was the amount of energy that's required to increase its temperature. We talked about specific heat we looked at a science experiment looking at the specific heat of sand versus water, if you remember. And water has a very high specific heat, which means it takes a lot of energy to increase its temperature. And for it to cool off. We talked about weight as well. You can take something's weight. All of these are physical properties of matter. And what makes physical properties of matter unique is that they do not change the identity of the substance. When we observe a physical property of matter, the matter stays the same. Nothing happens to the matter. It does not alter its chemical composition. So, chemical properties are different than physical properties. We said that they are determined by a substance's ability to react with another substance. When matter undergoes, or if we are going to actually observe a chemical property of matter, we would say that in order for us to observe that chemical property, the matter has to undergo a chemical reaction. And so if we're observing a chemical property, the matter does not stay the same. So when we look at two chemical properties of matter, the two main chemical properties of matter that we would look at are reactivity and flammability. Matter can react with air, and when it reacts with air, it can rust. It can tarnish, which means it changes color. It can corrode. We know car batteries can corrode, and food can rot. Or we can look at how it can react with water or different acids. And so we said that the other chemical property was flammability, the ability for a substance to catch fire. Now, when we look at these chemical properties, the matter does not stay the same. We have a chemical reaction that's involved, and we have a new substance that's going to be created. So now let's practice with some of these physical or chemical properties. The ability of gunpowder and fire to explode. So ask yourself, is the matter going to stay the same? The matter is going to stay the same. That means we have a physical property of matter. If the matter is going to change and there's going to be a chemical reaction in order to observe this property, we're going to get a new substance. That's a chemical property. You said this was a chemical property, you'd be correct, because the fire, or in order for something to explode, we're going to get a new substance, and there's going to be indicators of these new substances as well. The color of a sunset. Oh, I'm sure that you all are at home enjoying your beautiful sunsets and sunrises. Well, observing just the color of it. So this sunset here has many colors, purples and pinks and everything. No, the matter's staying the same. We're not getting a new substance. Physical property. The ability of a nail to rust. Again, that's a chemical reaction that's going to happen. We're going to have a new substance. That rust is the new substance. So we're going to have a chemical property being observed. The shape of a leaf. Okay, whether it is a maple leaf and has more of these little, prongs coming up here. Maybe you're looking at a pine needle or something. The shape is a physical property. The matter stays the same. The ability of wood to burn. Again, flammability here. So we're getting a new substance. There's indicators of these new substance, which we'll talk about in just a little bit. So that's going to be a chemical property. The hardness of a diamond. A diamond actually has a very, very large, I guess you would say, a greater hardness than other substances. I believe you actually have to use a diamond to cut a diamond. But this would be a physical property because we're not getting a new diamond by just denoting the hardness of a diamond. All right, the volume of your Coke. That could be 12 ounces. And so just by saying it's 12 ounces, we're not getting something new. The Coke is still the same physical property. The mass of 2 camels. I don't know the mass of 2 camels. Maybe you know the mass of 2 camels, but the camels would stay the same irregardless. So physical property. All right. This is a little more interesting, looking at the difference between a physical and chemical change. When we look at changes, we are actually altering the matter. When we look at properties, we are just describing matter. We're looking at characteristics of matter. Changes are a little bit different, where we are actually going to alter the matter in some way. So when we have a physical change, it is a change that occurs without changing the identity of the substance. Well, what does that mean, the identity? Well, we'd be talking about the chemical composition. We'd be looking at the arrangement of the atoms and their chemical bonds. Do those chemical bonds stay intact, or are they being rearranged to form a new substance? Well, with a physical change, the matter does not change. The atoms are staying as is. Bonds are not being broken. Bonds are not being rearranged or anything. Stays the same. It does what? Stays the same. Thank you. So with that, we have no new substance being formed. Some examples of these physical changes that we've talked about are a change in size, shape, color. If I were to get a haircut right now, as all these salons are closed, which really need a haircut, I don't know about you, but anyways, that would be a physical change. My hair would stay the same. Pencil shavings, torn paper, crushed ice. Again, looking at changing the appearance of it in its shape or its volume. Sugar dissolving in water. Remember, a lot of the kids think that solubility is a chemical change because you dissolve sugar in maybe your Kool-Aid or something and it looks like it disappears. Well, it's still there. You can taste it. Your Kool-Aid still tastes sweet. It is a physical change. Okay, like solubility is a physical property. It is a physical change. Painting your walls at home. Maybe some of you are doing some, at-home projects. But anyways, that would be physical change. So moving on to chemical changes. When we have a chemical change, we also have a chemical reaction. When a chemical reaction happens, bonds are being broken and they're being rearranged. It is a change that occurs that causes the substance or the identity of the substance to change. With this, you have a new substance with new properties that are being formed. Again, that's very important. Your new substance, the product, is totally different than the original reactants. And since it's totally different, it has its own properties that are unique to itself. So, how do we know we have a new substance? Well, there are clues or indicators of this new substance. Some of these that we said were that a new color appears. So that's a new color that wasn't there before. So if I mix together two clear liquids and now all of a sudden it's purple, well, that's a new color that wasn't there before. So let's see, bubbles. Bubbles or fizzing indicate to me a gas is being produced. So that's a sign that we have a new substance. We use this word precipitate. Again, that's not precipitation. We don't mean rain outside. Precipitate is different. This is a special science word that means a solid was being formed. Heat is produced. Heat, light, or even sound, all of those are examples of energy. So if we have a change in temperature, if we have light or sound being given off, those are all energy changes. And those are clues to us that we have a chemical reaction or a new substance. Let's see, moving on here. Oh, they are difficult to reverse as well. They can be, but they usually require another chemical reaction. Not all chemical reactions can be reversed. So let's look at some examples here. Reactions with acid. So we have combined vinegar and baking soda 1,000 times in class. When this happens, we see bubbles being formed. And that bubble is that new product, carbon dioxide gas. Sometimes we have substances react with oxygen, and that's an oxidation reaction. So when iron reacts with the oxygen in the air, and under some moisture conditions, we have rust being formed. Rust is a new substance. You can see the color change that's there as well. This is a chemical reaction. Sometimes you can have reactions with electricity. Reactions between substances. So sometimes you can combine two different substances and you see a chemical reaction taking place and you have the formation of like with sodium and chloride coming together. Sodium is that metal, that really highly reactive, flammable metal, and chlorine is a green gas. And when they come together, you've got table salt, which is that white crystalline solid. Silver plus sulfur in the air is going to make it tarnish. So we have that color change. Other examples of chemical reactions, when we burn wood, there are several indicators that we have a chemical reaction there. We have a color change. We've got heat given off. We've got smoke or ash given off. When metal rust, food digesting in your stomach, gasoline burning, a cake baking, all of these show new substances being created as a result. Okay, so let's put yourself to the test. Physical or chemical change? Water evaporating from the ocean. Be careful now. Be careful. Oops. Let's go back here, Miss Jacobs. Okay, so when water evaporates from the ocean, we have a physical change. A lot of the times kids get that confused because they think, oh, Miss Jacobs, a gas is being created. Well, no, what's happening when we have a change in state of matter with the addition of heat or the taking away of heat is we just have the atoms moving closer or further apart. There's no change in the arrangement of the atoms, just a change in the space between atoms or their speed. So when we have melting, freezing, evaporating, sublimation, if you remember that word, changing directly from a solid to a gas, those are all changing in states of matter. And so those are all physical changes. We have no new substance being created. The yolk of an egg, which contains sulfur, causes tarnish to form on silver. So this would be an example of a chemical change. This color change over here is showing me that a new substance is being created. The ice on a lake melts to become water in the lake. Well, again, your keyword here is melting. So this melting here is telling me that we have a change in state of matter. So again, that's going to be a physical change. Charcoal in a fire turns to ash after several hours. Well, here we've got the fire working here. So we've got these coals are burning. So right here we see indicators of a new substance. It's turning white. We see a temperature change. And so these are all clues to me that I have a new substance. Again, chemical reaction. A pencil is sharpened in a pencil sharpener, leaving behind shavings. Well, no, boys and girls, this is just a change in its shape. So, and even looking at the volume maybe of the pencil. So, no, a new substance is not being created here. So, this is a physical change. A battery makes electricity to turn on a flashlight. So this is looking at the physical property of conductivity here, the ability for something to pass an electric current through. With this, we are looking at another physical change. Conductivity, we said, was a physical property, and so some substance can pass an electric current through. And so that would be physical change. A bicycle rust when left in the rain. So right here, we're seeing this color change, that reaction with the air. So that is a new substance, and new substance is a chemical change. A shirt is accidentally torn in the washing machine. Mine get holes in them, losing socks here, absolutely. But anyways, this is a change in shape. And so just like ripping a piece of paper, this would be a physical change. The shirt itself is not being changed into a new substance. A log is split in two by this woodsman here. So again, just changing the shape. There is no new substance being created. So all of these boys and girls, going back to the beginning of chemistry, ways that we can observe and change matter. So sorry, this is my practice video is a little rusty. I'll get better. The jokes will get cheesier. Thank you for joining me today. And we'll be looking at some more chemistry this week and doing some more review throughout this quarantine. I hope you guys are having a great time at home, and I will see you all later. Bye-bye now. How do I get out of here?